Number 6, the first 5 were short problems. Fall 2011, exam 3. A 3,000 pound tractor moving at 12 feet per second along a horizontal track. It drags a 1,000 pound sled. Resistive force versus distance is shown in the graph. How far is the tractor able to pull the sled before coming to a stop? Okay, so very important to understand what our graph means. We have force and distance. All right, so this area defines the amount of work done over a particular distance. Okay, how far? That's a distance. So we don't know the distance on this graph. Okay, we're going to assume that it's more than 4 feet. All right, so we're going to just label this D right here. Okay, and so we're looking at this area right here. If D would happen to come out to somehow to solve to be less than 4, that would give us an indication that our assumption was wrong, and we'd have to go back and rework this. But let's work it this way, see what happens. So conservation of energy. Okay, I won't include springs, but I'll go ahead and write everything else out. K0. We've got a horizontal track, so that's going to be 0. Okay, and it's going to be final kinetic energy plus final gravitational plus E loss. Okay, so we set a horizontal track. Those are both 0. Coming to a stop. That means our final kinetic energy is 0. Okay, so now we've got to just determine how to account for this work done by the resistive force. It's a resistive force, so it's really a loss. Okay, so the work in is 0. Okay, because we're not given any information about that. So basically, the tractor's engine stopped pushing, and we're just going to see how far it takes us to stop. Okay, so that leaves us K. Kinetic energy is equal to energy loss. 1/2 mass velocity squared is equal to the area. Okay, and we're going to calculate the area as this area, 600 pounds times 4 feet, plus, okay, in this area. So that's going to be 900 pounds times D minus 4 feet. Okay, and the mass of the tractor, let's see, so go ahead and write that out again, is 3,000 pounds divided by 32.2 to get it to a mass. Initial velocity 12. Okay. Is equal to 600 times 4 pound-feet plus 900 D minus 4. pound-feet. All right, if we look at units over here, feet over second squared, feet over second squared, feet over second quantity squared over feet over second squared. It's going to leave us with a foot of this units and then pound. So all these things have units of pound-feet. So just left to solve it. It's pretty simple, but I'll go ahead and use the solver just like you would on your calculator. So 0.5 times 3,000 divided by 32.2 times 12. Okay, move this over to the other side. Times 4. And then move that over the other side. Minus 900 times d minus, I'm going to use x, minus 4. Okay, double check my solution, and looks like we get 8.79 is our answer. So D equals 8.79 feet. So 8.79 feet. Just a note I noticed in checking this one, looks like we have a mismatch between our posted blank PDF file and the solution file. It had a 4,000 pound truck in the solution file, so it gets a slightly different answer, but the procedure is exactly the same here.